So superconductors are created, so all of a sudden that opens up the technology for hover cars, for train systems that are on these magnetic rails, better than what we have right now. We currently have magnetic trains, but these would be even cheaper. The problem with superconductors today is that you have to, in order to make one, you have to get them about 200 degrees below Fahrenheit, or Celsius, doesn't matter. Really, really cold in order to make a superconductor. And so now if you can develop a material that would do it at room temperature, all of a sudden you wouldn't need to keep it cold, which means you could create it, and there you go.
Okay, so that's why that's significant.
Yeah, it needs to be room temperature. Otherwise, you need to keep it in like some sort of liquid nitrogen, which is very hard to do when you have your road made out of a superconductor. It'd be impossible, basically.
Yeah.
So this eases the tension a bit of the fossil fuel problem, because now we don't need as much of it. We're still relying on it, but we don't need as much of it. The other discovery that starts to help us realize that our energy problems are coming to an end is that the very first dark element has been discovered in the asteroid belt. This is significant to the history of dark potential, so I'm going to spend a bit more time on this. I talked about this in another video, so I'm just going to go over it briefly. But I've made up the science for dark matter because I wanted to, and because it's still one of those theoretical science that I can. And I can make up whatever I want, as long as it conforms mostly to our current theories and standards and laws and everything, then it's good. And most people can kind of accept it, except for those true fanatics out there who don't actually know what they're talking about, because we actually have no idea what it is, so I can make up whatever I want. I'm talking to you, whoever is about to write the comment, "That's so wrong, that's not how dark matter can be." I just don't care, really don't care. So, this dark particle, this elementary particle, I just don't know what to call it yet. I'm going to call it a dark particle. So like an electron, quarks, and dark particles. We have all these different kinds of elementary particle. An elementary particle is a particle that is not made up of anything else. Does that make sense?
Yep.
Like a photon or a proton is actually not an elementary particle. Neutrons are not elementary. They're made of quarks. So you can actually go deeper and find something that they're made out of. Quarks are theorized to be elementary. Electrons are theorized to be elementary. Photons are theorized to be elementary. And so are dark particles. Well, in the asteroid belt, they find that these dark particles are actually part of regular molecules or regular atoms, that they join the nucleus along with protons and neutrons. And this is a ridiculously huge discovery, because up until that point, everything was theorized to be made out of protons and neutrons. Every atom, every molecule, everything that you see in the entire world and theorized in the entire universe was made up of protons and neutrons with electrons flying around them. But they found this actual matter, and it acted completely different than what they thought. Like it just created this whole new level of the periodic table.
You plane?
Yeah, like you have your periodic table. Now you have your periodic table with dark particles inside of it. And heck, you have different levels because there might be a different number of dark particles within that atom.
Are they different elements, or are they dark versions of existing elements?
They're dark versions of existing elements, but they act differently than the existing elements. So we can call them dark hydrogen, which would be a single proton mixed with dark particles, but it doesn't act anything like hydrogen.
Oh, okay.
It's just easy to call it dark hydrogen because
it has a little bit of hydrogen in it.
No, because it's the same structure as hydrogen, except for the fact that it has dark particles in it as well.
As well, right.
Yeah, so it's like a heavy dark, or it's like a heavy hydrogen or something. Right now we do have different kinds of atoms. Like, for example, it's the number of protons that determines what it is, right?
Right.
One proton is hydrogen, 2 protons is helium, so on and so forth. The number of neutrons added to it does not change it from being a hydrogen element or atom to something else. It just changes, like I think it's is it the isotope that changes when you add more neutrons? Going back to high school chemistry here, I can't remember. I think it's the isotope that changes. Like when you've heard the word isotope.
Yep.
Like uranium-238 or uranium-235. I think the difference between those is how many neutrons are inside the atom. Correct me if I'm wrong. It doesn't matter because it doesn't affect what I'm talking about here. So here is the crazy thing about dark elements. They find it in the asteroid belt. So in some asteroids, they actually find this material. And as they analyze it, they actually find dark particles inside of it because they know how to find dark particles. That was discovered like a couple decades before at least. The thing is, it affected that matter in such a way that the research shows that it has very unusual attributes that allows it to being used with it and shining different kinds of radiation on it. you can actually have it manipulate the force fields around it. When I say force fields, I don't mean a force field, like the something bounces off of it, but I mean like the gravitational force, you know, like a magnetic field.
Yeah.
That's a force field.
Yeah.
There's a field of forces. And so you can actually manipulate the different types of fields around basically the energy fields around these molecules. And the ones that they discovered pretty quickly were gravitational was the most obvious. They were able to manipulate gravity. And the way that they discovered these dark elements was they found asteroids that were heavier than they should have been. Like they measured the asteroid based on all of their normal things, and like, this asteroid should be this heavy, but it's not going around the sun according to something that's that heavy. It's going around the sun according to something that's heavier. And they found that these dark elements were not heavier, which didn't explain the difference in weight, but that they manipulated the gravitational forces around that asteroid and made it appear heavier, when really all it was doing was making gravity stronger, which then, of course, makes something feel heavier. If I took an object like this tank and I increased its gravitational pull, or the Earth's gravitational pull on it, it would feel heavier, when really it's the same. It's okay.
It reminds me of a Demon Prince one time.
It's still good. It's still good. See? It wasn't glued on. Okay. Anyway, so even though... sorry. Your heart stopped there for...
A little bit.
It's plastic. It's okay. If it was metal, then it would be like a clunk and everything
Metal
would shatter. Yeah. They used to have those. Anyways, if it would, even though there's the same number of molecules inside of this and the same number of protons and neutrons, if I were to increase the gravitational pull, it'd feel heavier. It'd feel like there's more, but there's not. It's just that it's... Because weight is a factor of gravity. Our mass, if you learned in science, has nothing to do with weight. It's the amount of elements that are inside of you.
You know what? That's like a scale, okay? You put your hand on it, and you press down on it.
Yeah.
Is your hand heavier?
Exactly. And yet it's going to register heavier because you're adding to the force that's happening to that scale.
Do I have paint in my hair?
Did you just put that in your ear, like a pencil?
Is there?
No, there's not.
Oh, okay.
Did you
felt
put it? Did you put it
something.
there? Okay.
Yeah.
That's awesome. Anyway, so they found that dark elements, when exposed to radiations of different kinds, they were able to manipulate these fields around it, which is just this extraordinary discovery. Just completely rewrites a lot of the science books, because like Einstein looks at the universe, his equations developed, looked at the universe as being made of the same stuff, and he was just trying to explain it. And even the whole dark matter, dark energy conundrum is based on the fact that we're observing the universe and it doesn't make sense. Because when you look at the universe, when you look at a galaxy, if you think about it, if you're spinning, when you spin something, when it gets closer and closer, it spins faster and faster, right?
Closer to what?
To the source that you're spinning. Like you're spinning really close, it's fast. When it's really far out, it's slow. Yeah. Well, you observe that in the solar system. The planets on the outside, they go the slowest.
Yeah,
and the ones in the
middle longer to...
No, not just takes them longer. They're actually going slower.
Well, right.
Of course it takes them longer because it's a larger, but they're actually going slower in proportion. And the ones in the center are going faster in proportion. Not just how many times they rotate around the sun. Obviously that would be faster because it's a shorter path, but they're actually going faster. But when you look at the galaxy and its rotation, when you look at the neighboring galaxies, the stars on the outside are rotating just as fast as the ones on the inside. And that doesn't make any sense whatsoever. That throws all the gravitational laws out the window, which is why they had to introduce this dark energy, which is 75% of the energy in the universe. Basically, they can't account for 75% of the energy and matter in the universe. And so they make up this thing called dark matter and dark energy to account for that, and then it makes their equations work.
It's like views on our videos, 70% unknown. Where the views come from, unknown.
Yeah, who knows, right?
Yeah.
So we just make up something, right?
Yeah.
But then they discovered that their calculations were completely off, because what they didn't know was that these dark elements actually shifted how much gravity there was. And so all of a sudden, the calculations are worthless, because until you find out just how much these other dark elements are manipulated on other things, you can't actually know the mass of anything from a distance. So it throws off all astronomy, for one thing.
Made everyone dumb.
Not dumb, just incorrect. A lot of the theories are still all, like, you know what, it doesn't throw out the theory of relativity. It doesn't throw out Einstein's theory, or all these calculations. The calculations are right. It's just that when they're looking at the amount of matter that's in the universe and energy that's in the universe, they're wrong. That's where they're wrong. And that's where this comes in. Does that make sense to some degree?
Yeah, sure.
I realize this is like a new science. So I understand that not everybody will They might have to kind of look at this a few times. It took me a long time to come up with this idea.
I understand that you're speaking English, and that the words that you're saying, I understand the words that you're saying, and I understand the feelings and emotions that you're trying to convey at me.
Well,
I'm kidding. It actually does make sense.
Okay, let me break it down to the simplest. Not because you don't understand, because I know that you said you just did. But let me
also because you described it a couple times before. So
yeah, let me break it down to what matters for the game. What matters is there's this new type of matter, dark elements. Not dark matter, because dark matter, if you use that word, it means something else, because we currently have something that we call dark matter. It would actually be called dark matter otherwise. It's dark because it does not influence photons or electromagnetic radiation, and so it has no bearance on anything to do with light, which is why we call it dark matter. It's dark elements because it merges with our own elements to create a different periodic table. We don't find any of this on Earth, though. This is not a naturally occurring thing in most places. It's just kind of strange how they discover it. And there's lots of theories of all these things. In fact, they eventually discovered it on Mars and other areas as well. And it becomes something to mine. It actually is a valuable resource because with it, all of a sudden you can manipulate all these different forces. And you can kind of start to use your imagination on what you could do with that. So there's a new type of matter, a new type of elements that when exposed to the right kind of radiation will basically create magnetic stuff, gravitational stuff, nuclear stuff, all this. So this leads to a new type of energy source, which is fusion. Fusion, the major problem we have with fusion right now is that the only place that's really capable of doing fusion is the sun, because you need to have a ton of gravity and a ton of heat to get hydrogen atoms to smash together and turn into helium. That's the major problem that we have. They've been going through all these different things. They have these huge amounts, this huge facility with tons of lasers, this real life, that they've tried to create fusion. But the problem is they put more energy into it than they get out of it, because they're like just trying to heat up the thing to hot enough to create fusion. So that's the problem. Right now, fusion is hot. You have to get it really hot. And the reason you have to get it hot is because what heat actually is molecules vibrating.
Really quickly.
Yeah, and the slower they're vibrating, the colder they are. Absolute zero is the point where they're no longer vibrating. That's like minus 300 degrees Celsius or 270 something, whatever it happens to be. It's very cold. And so when we talk about cold is just a lack of vibration. And so if you get something hot enough, they're vibrating so quickly that they smash into each other. Now, the reason that they won't smash into each other easier, even though there's tons of hydrogen all around, is because hydrogen is a proton. Protons have a positive charge. The other proton has a positive charge, which means when they get close together, what happens? They repel.
Yeah.
Yeah.
Like magnets.
Except that they're just positive. Magnets will flip over and they'll stick. These ones are just positive. The reason that a hydrogen atom is neutral is because it has an electron going out that cancels out that positive, and it becomes neutral. But when you get them close enough, it gets past the electron, and it gets close enough that all of a sudden they're both positive and they push each other away, which is why you don't just see natural fusion happening in nature. You don't just see hydrogen smashing into each other and letting out these enormous explosions and turning into helium, because there's too much of a charge. But you get them hot enough, and they move so quickly that they kind of get past that difference, and they get close enough that the nuclear forces, which are very short range but very strong, take over. And those are powerful enough to pull them together. And when it pulls them together, it becomes lighter for some reason, and that gives off energy because of E equals mc squared, obviously.
Obviously.
But it doesn't matter. It needs to be hot. Well, if you can manipulate gravity and create a stronger gravitational pull without heating it up, which you can do with dark elements, all of a sudden you can get that hydrogen to crush together.
Therefore, you can get fusion.
Like the sun, except you don't need as much hydrogen as the sun, and you can make fusion at, maybe not room temperature, but not too hot. And so you're able to create fusion power. We call it dark fusion because it's used dark elements. So that creates dark fusion. It's not commercialized yet, but it's discovered.
By who?
I don't know. Somebody.
Okay.
A scientist.
Oh, okay.
Let's say an Italian scientist. The German scientist is going to do the AI, so I might as well let the Italians get something right.
Discovered the fusion! Oh, mamma mia! Alberto! Verite! Sorry, I couldn't help myself.
Actually, we'll make it like Canadians or something.
I just get fusion, eh?
I just,
Whoa.